Okay, so bad news is JASP does not give us the fitted values, as far as I know, for ANOVA that we need here. Good news is, in doing it in Excel, one, we'll get a much better sense of what's going on, and two, I'm going to throw out some Excel pro tips as we go along. So our first order of business, just to clarify, we have two factors of interest we're looking at. One is the province, so there's these two true provinces, and then we have the two biological sexes in our data here, male and female. What we need to do is fill out, or this is actually a helpful way, I mean we could do it other ways, fill out a table of the average for each of these breakdowns, I guess you could say. So this value here should be the average attitude towards Swahili, average score for Nairobi males. This should be for Pawnee females. This one here should be the average score for females in the data set. And this one here would be the grand mean overall. So let me just jump right in and start filling some of these out. The grand mean is the easiest. All we need is the average of this entire column C. So that one's as simple as average C colon C. And that'll give us our average attitude score of the whole data set at 147. As we move to these row and column totals, it's a little trickier, and there's a really cool formula. So essentially what we want to do is take the average of these scores, but only if the value of this, in this particular case, would say Nairobi. If this says Pawnee, which it does later in the data set, we don't want to include that into the average. Now you could do this with a filter, you could do this with rearranging, sorting your data, or there's a cool formula called average if. And what we're doing with average if is we're telling it what column to look in for our if criteria. So in this case, it's going to be column A. And the criteria itself would be if, let's see, if it equals, I'm going to not use case sensitive. I just want to see what will happen here. And then my average range, where I'm actually taking the average of, like what are the numbers that I'm taking an average of, that'll be in column C. So I'm going to do C, C. Yeah, okay, so it's not case sensitive, the string. That's good to know. So 138.90 is the average of all the Nairobi students. So notice that the average Nairobi is a little bit lower than the grand mean. In other words, the province effect for Nairobi is going to be negative. If you're from Nairobi, if I don't know where you're from, I'm going to predict you're at a 147. If I know you're from Nairobi now, I'm going to lower my prediction of where your attitude will be, just because in general students from Nairobi in this data set had lower attitudes or more negative attitudes towards Swahili. Okay, so using that same principle, I'll let you fill in these. Let me fill them in real quickly. Okay, and now we need the more individual cell blocks. So specifically, what would be the average for a Nairobi female? And again, we could put them in order, sort them. We'd have to sort two columns to make sure you get all the Nairobi females, or essentially we want two if statements. We want an if they have a Nairobi value here, and if they have a female value here, we want the average. So what could we get this average of two if statements? Well, average ifs. Look at that. Crazy. Okay, now a thing to be careful of here, the first value of the average ifs function is the range you're taking the average of. Notice that was the last one. If in the just plain average if, that came at the very end. Here it comes at the beginning because we may have a whole bunch of criteria, so it wants us to get that average out of the way first, and then we look at the criteria. So now my criteria range 1 would be A, and I want this value to be Nairobi. I've got to spell that right, it's a string. Next criteria range would be BB. I want that value to be female, and I'll press enter, and I'll get a division by 0. I did not spell Nairobi right. Just wanted to make sure I could show you that error. And that'll give us this. And you can do a similar thing here for these three. Actually, I'll give you one more real little tip here. I can Control All or select it, copy this to the clipboard, and then press Escape. If I would go down to this cell then, click up into the formula bar and paste, all I need to do now is adjust this for male. And then I could paste the formula again here, and here I just have to adjust it for Pawnee female. So it's a way to get those formulas a little quicker. I'll just go ahead since I'm already here. And Pawnee male. Okay, so now I have this entire chart filled out. So where do I go from here? Well, first of all, I want to get the grand mean. The grand mean is just the average of the entire data set. I could just get average here, but to call from the chart and get used to doing that, I'm going to do this. Now, if I were to copy down, these are going to be 0 because this is actually just a formula here. What I would want to do is copy this, right-click, paste as values, and now I have the actual value that I can copy down. Here, the province effect, so for Nairobi, this is going to be a negative number. For Pawnee, we're going to be a little higher than the grand mean. But in general, I just need to set up an if statement and take a peek. If this value equals Nairobi, spell that right, then my province effect is going to be, well, it's going to be the grand mean, it's going to be the Nairobi mean minus the grand mean. That's going to give us about a -8 there. Otherwise, if it's not Nairobi, in this case I only have 2 values, so I can just go straight here. If I would have more than 2, I'm going to have to use a nested and if, which I'll get to in just a second. So if this is not Nairobi, then I'm just going to take the Pawnee value minus Q6. Now, if I were to paste this formula down, it would not do what I want it to do because I want this A2 to move as I go down the spreadsheet to then A3, A4, A5, but I don't want these cells to move. I don't want it to slowly go down on that little grid there also, so I need to freeze these cells. On my computer, if I do Windows F4, that lets me put these dollar signs. You could manually type in the dollar signs here yourself, or you could Google it, how to do it on your particular computer. So there I'm having a -8.2 province effect for anyone living in Nairobi, and if I scan down, I should have a +8.2, there we go, for anyone living in Pawnee. Okay, I'll let you do the same thing here for sex. You're going to use an if statement. Okay, and you should have a positive effect for any female, negative effect for any male, because females in general tended to have a more positive perception and attitude towards Swahili. And then we have what's called the additive fit. So if we had no interaction term in our model, going back to chapter 6, we would just have the grand mean plus whatever province you're living in, the effect from that, plus, and when we say effect, we don't mean cause and effect, we just mean the extra explanation, I guess, coming from that, or the extra prediction. So this first female, for example, would have the grand mean of 147, but a little bit lower because she lives in Nairobi. She would have that province effect, and a little higher because she is a female, and the females tended to have a higher attitude. So when we say additive, it's pretty nicely matching the formula, which is just adding those 3 values, and then we copy that down. Now, the cell average, this is going to be the trickiest formula to do. The concept is simple. What we're doing is we're taking, this is a Nairobi female, so we want this value to appear, this 147.025, and it's always going to be one of these 4 values depending on what their values are in A and B. So there's a couple ifs going on here, and one way that I would do that is a nested if statement. So I would do if, and my test here is going to have an and in it, because I'm looking not for one thing, but two things. If actually I'm going to do A2 equals Nairobi, and B2 equals female, well, if it has both of those things, then I want the value of 147.025. If it doesn't, well, then I'm going to look to see if it has A2 equals Nairobi and B2 equals male. And if that happens to be the case, close that and out, then I want to give it a 130 blah, blah, blah. And if neither of those are the case, then I'm going to do another and A2, whoops, and let's get a little confusing. A2 equals Nairobi, and A2 equals 20, and B2 equals female. Close that out. Then I want to give this value, and we do get a little freebie here. So then if that's not true, whoops, and if that's not true, we want this one. Yeah, I figured I had. Okay. So if we have and here, and we needed more if statements in there. Okay. So this is nested if. So around each of these ands, essentially, I need a if. Okay, that should be better. I may have, I missed a parentheses at the end there. And if that was premature, if not if, and this one also was premature. There we go. And that one I think is just a print. Yeah, okay. So 147, and it's rounding. That's okay. The true value is still in there. I can't paste down because, again, I need to freeze certain cells. Anything in O and P, basically, I need to freeze. Okay, and that should take care of my formula. And then if I paste that down. Okay, the interaction is just what our cell is over what that additive fit would be, how far off of what that simple two-way prediction would be. The fitted itself is now the sum, similar to what we had before. We have the grand mean, the province effect, the sex effect. I'm holding down Control key, by the way, so I can select multiple. And then the interaction effect. We don't need those two. They're factoring into the interaction effect. Okay, that's the fitted value. And then the residual would just be whatever my actual is minus what the fitted value is. And that will now be what we can plot. Okay, so if we highlight those and insert a scatter plot, that will give us what we need.